Hello, welcome to Block 3, Equality and Equivalence, Lesson 7. I'll share my screen. Okay, in your previous lesson, you learned about the meaning of equivalence and how to use the equivalence symbol. In today's lesson, you will learn how to simplify algebraic expressions by collecting like terms using the equivalence symbol. But before we start, I would like you to do the retrieval practice questions, or some of you call it starter, to get you thinking about maths, okay, and about what you learned in your previous lessons. I would like you to pause the video and answer the questions in about 3 minutes. You should be able to do it in 3 minutes, but you can work at your own pace. You don't have to rush. What is important is you having to learn something new and to build your foundation, really solid foundation in maths. Okay, assuming you've paused the video and you've really thought about this work, you've worked hard on it, here are the questions, here are the answers. Let's discuss them. So the first question asks, what is the symbol used to show that two expressions are equivalent? All right, it is the three lines, okay, one on top of each other. And then here you were simply asked to work out the calculations. You could have used a calculator, but I would have advised you to use to do it without a calculator. And then for question 3, you were asked, show that the statement below is false. So all you had to do was to find, some numbers that would prove that, this is false. So substitute values for k. The expressions are only equal when k is 1. So you could have substituted maybe 1 or 2 or maybe 2, 3 or 4. Okay. Just to prove it wrong that 5k plus 2 is not equivalent to 7k. By now, I hope you still remember how to do substitution. If not, you can go back and watch the video on substitution. Okay, let's do some new learning. So, if I give you this expression 3a plus 5a, what do you think it's going to be equal to? Yeah. So if we use the bar model to represent this is what we'll get. Now remember from our very early lessons, if we use the bar model to represent this, 3a is 3 lots of a. Okay, 3 lots of a. And then this is this a here, and 5a is 5 lots of a. So when we simplify this, that is the word we use. When we simplify this expression, we are going to get 9a. Okay, 9a. So remember, have you noticed that the terms are like terms? Again, you can see what we learned earlier is becoming useful here. What are like terms? I'll remind you, like terms have the same variable and the same power. So you can see they all have a. Okay, so remember, in algebra we call the letters variable, and I hope you still remember what we call the numbers coefficients. Okay, so you can see here that we have the same variables and then the powers. So this a, we can say they have power 1. All right, here is the one we did before. It's exactly the same. I want you to think about these. What do you think would happen? Okay, For this one, we're clearly going to have 9a. We've done this before. For this one, what do you think? We have 3 lots of A, add A, and we have 5B, 5 lots of B. So if we want to use the equivalent symbol, but after simplifying this, we're going to have 4A add 5B. That's what we'll get. And then for this one, have you noticed that there are no like terms? How do we write this one? Interesting. I think some of you may have guessed this. It's going to be exactly the same. Okay, the expression on the left will be the same as the expression on the right. We do not have like terms to simplify. So the equivalent expression will be the same. All right, here is something for you to think about. Can you spot the mistake? Right, let's discuss it. So here, what the person would have done is this. So they have, so this is the 15 here. But what they clearly did is they added these two. Okay, that shouldn't be the case. What they should have done, if we have spotted the mistake, is they could have done 15, 15x subtract 4x and then add 2. So 15x subtract 4x, that will give you 11x. 11x add 2, that will give you 13. So I hope you learn from this, because when you start simplifying expressions that have like terms, you really need to be careful and to watch out for mistakes like this. So let's move on. So in the end, this is what we should have done. So our answer should be 13x. Okay, before we move forward, for you to have practice, you need to realize that what we've learned so far is when you have algebraic expressions that have like terms, we use the word simplify, meaning things that have like terms can either be added or subtracted from each other. But on like terms, things that are not like terms, we cannot add them together. For example, we cannot add 5a plus b. Okay, if for example I have 3a plus b, we can only write the expression when we simplify it as 4a plus b. Okay, now have a go at these questions. Pause the video and have a go at questions 1 and 2. Assuming you've paused the video and you've worked through question 1 and 2 for about 4 minutes, here are the answers. Let's discuss them. For question 1, you were asked to match this expression to its simplified form. In its simplified form, these are the expressions that match their simplified form. So for example, I'll just discuss this one. 2b minus 7b is equal to negative 5b. Just in case you do not know how to work with numbers like this, my advice is for you to use a number line. So, this is just like saying 2 minus 7. The only difference is we just have letters in front of them. So if we use our number line, okay, and I can carry on as long as I want. I just need to draw exactly what I need to solve the problem. Let me use blue. So we have 2 minus 7. Let's work that out, and then we'll put the letter in front, right? Because it's just, you know what it is. It's just numbers with letters in front. So we have 2 minus 7b. So 2, we start at 2. Minus 7 means you do 7 steps to the left. So 1, 2, 3, 4, 5, 6, 7. See that? Negative 5. And then we'll just put b in front. Okay, so it's important you know how to work with negative numbers like this. All right, let's move on. And then for question 2, you were asked, Mo and Eva are simplifying expressions. Tick the correct answers. Okay, so you can see these are the ones that are the correct answers. 9a minus a is 8a. For example, b plus b is 2b. 3a plus 3b. We cannot simplify that any further, so we just write that the way it is. Okay, let's move on. Pause the video and have a go at questions 3 and 4 in 4 minutes. You may take longer depending on the pace of how you work. All right, assuming you've paused the video and you've really thought about this work, you've worked hard, here are the answers. So question 3, you're asked to simplify the expressions. So here are the answers for question 3. You can see we have 5 lots of H. So we just write 5H. Here we have, again, 5 lots of H. And then here we have 5 lots of H again. You can see different ways to write 5 lots of H. And then what do you notice about your answers? Okay, they are all the same, different ways of writing the same thing, of, having different expressions that you can simplify to give you 5H. And then 3C, you're asked to write 5 expressions that are equivalent to 3G. So you can just get ideas from the 3A that was done before, and then that should be able to give you these answers. So different ways. Okay, here are the answers for question 4. So here you were asked to simplify the expressions by collecting like terms. Collecting like terms mean you put things that have the same variable, so that are like terms, that have the same variable and powers together, so that you can either add them or subtract them if you have subtraction to do. For example, this one. Here, you can see. And then here, all right? So these are the answers for these tasks, All right? Here and here. Okay. What about if we have things like this? So take note that we've been using the bar model to help us do these calculations, collecting like terms, simplifying, which means to add or subtract like terms if you need to do so. But bar model helps us get to a point where we think, I get this now, I really don't need to be using this anymore. Well, let's apply that idea here. So we have 5d squared plus 2d squared. So 5d to the power 2 plus 2d to the power 2. Of course, you can see straight away that these are like terms. So we can simply just have 7d squared as our answer, the equivalent. Okay? And look at the equivalent symbol. What about this? Have a think. What do you think the answers will be? All right. I'm sure you would have thought that, well, these ones are like terms, right? So this is simply 3d squared. But this one, have you spotted that this might looks, that doesn't have a power 2. So this is not a like term with the 5d squared or the 2d squared. So these are the only two that can go with each other. So we can now see, have you also noticed the way we have circled the sign that goes with the coefficient before the letter or with the variable? Let's start using the correct word, variable. So we'll do 5d squared minus 2d squared first, which gives us this 3d squared plus the 3d. Okay, we can't add this to that. They're not like terms. Remember what are like terms? Like terms have the same variable and the same power. This, they're the same variable d, but it doesn't have the power 2. What about this one? Have you spotted the mistake? Have a think. So this person seems right. They've done 15w squared minus 4w squared, which gives 11w, but what? Guess? 0. So that should be definitely wrong because they have subtracted the powers. We do not do that. Okay? You simply write what the result is. In this case, it should be 11w squared. Okay. All right, that should be our answer. Okay, now that you've learned, so we've got to the point where we've been using the bar model, we're really good at it. We don't need it anymore. And when you have powers, with algebraic terms that have powers, you should the know and stick to the definition of like terms that, okay, if I need to collect like terms, they must have the same variable and they must have the same powers. If not, I don't need to collect them together with the intention to simplify. Simplify means you need to add or subtract those terms that look alike. And what are the terms that look alike? They must have the same variable. You see the way I'm repeating this? They must have the same variable and the same power. Okay, you can have a go at questions 5 to 7. Pause the video and do this in 5 minutes. All right. Assuming you've paused the video and you've really thought about this and you worked really hard, let's look at the questions and discuss them. Question 5 says, it asks, explain why you cannot simplify this. They are not like terms. Okay, of course they are not like terms. Explain why 2b plus 3 is not equivalent to 5b. You cannot add these. They are not like terms, so you can't collect them. And then explain why you can simplify these. Yeah, we can simplify this because we have the 7k. You have k terms. The k are like terms. All right, so we can simplify them. So when we simplify, we'll end up with this. Have you noticed we wouldn't be adding the 3a to the 6k? So when we simplify this, we have 7k minus 3k, which is 4k, plus 2k, which is 6k. That's why we have that there. And then plus 3a. We just leave it like that. You don't need to do anything to it. It's right, okay? Don't say, oh, why? Why should it be like that? We cannot add them. They are not like terms. Here are the answers to question 6. You were asked to correct Dexter's mistakes. So here are lots of mistakes that Dexter has done. So when we correct the mistakes, using what we know, that we can only add like terms, and we cannot be fiddling with the powers like he's done here, okay, then we begin to get things right. So here are the answers. And then question 7 asks, is it possible to simplify 3pq minus 5qp? Of course, we can simplify that. Of course, we can. Remember, simplify means to add or subtract things that look alike. So, check this out. Did you remember what we said about guess the language? Commutative, right? So, this can be written as 5PQ. So, they're the same thing. Or we could have written this as 3QP. But remember what we said? We write things in their alphabetical order. Our very first lessons in algebra, right? So we can actually simplify this because this is actually as this 3PQ plus 5PQ. So can you see they're like terms? They have the same variables and they have the same power. So we can actually simplify them. Okay. Here is question 8. Pause the video for 3 minutes and have a go. All right, assuming you've paused the video and you've really worked hard through this, here are the answers. Let's discuss them. Here you're asked to simplify these expressions. Okay, here you can see you're beginning to work hard to collect like terms. We can only add the 3a to the 2a. That's why we have 5a. The 4b to the 3b. That's why we have 7b. And that's what we've done across all the way here. You only collect like terms and simplify them. Okay, here is question 9. Pause the video and do question 9 in 5 minutes. Okay, assuming you've paused the video and you've worked really hard, you can see here involves collecting like terms, really thinking about things through. Here are the answers. Let's discuss them. So if you think about it, what I'm going to show, I'm just going to show a few of them to see how we collected the like terms. So the way we collected the like terms is this 7a is going to go with the plus 4a. That's why we have that one. This one, the 6g, is going to go with this g. Have you noticed the way I've circled the sign that goes with the variable? Here, this 8y is going to go with this negative 3y. See the way I have circled the sign with it. And this one. So actually, we have 8y minus 3y, which is 5y, minus y, which is 4y. I hope by now you know that this is 1y, but we don't write it in maths. We just know it's 1y. Okay? And we follow the same process to do the others. Okay. So this brings us to the end of our lesson. So what have we learned so far? We have learned that you can simplify algebraic expressions by collecting like terms. Collecting like terms mean using like terms and you know what like terms are. Like terms are variables that have the same powers. And then simplify means you either adding or taking away those terms that are like terms. So you collect them and you simplify them. Okay, that brings us to the end of our lesson. Until next time, take care and bye-bye.